Negative of a vector. Welcome, everyone. Today, we are going to dive into a fundamental concept in vector algebra, the negative of a vector. Before we look at what a negative vector is, let's quickly refresh our memory on what a vector actually is. In our studies, it is essential to remember that a vector isn't just a simple number. It is defined by two primary characteristics: its magnitude, which is essentially its length, and its specific direction. Now, this brings us to our main topic. When we use the term negative in the context of a vector, I want you to be very careful. We are not talking about a negative length or a negative magnitude, because, as we will see in the next slide, magnitude can never be negative. Instead, when we speak of the negative of a vector, we are strictly referring to a complete reversal of its direction. Think of it as a 180-degree flip. Let's move on to the next slide to look at the formal definition of this concept. Conceptual definition. Now that we've established that a vector is defined by both length and direction, let's dive into the conceptual definition of a negative vector. Think of it this way. The negative of a given vector, let's call it vector A, is simply another vector that possesses the exact same magnitude or length as vector A, but it points in the exactly opposite direction. To make sure this concept is crystal clear, let's break it down into its two fundamental components: magnitude and direction. First, let's look at the magnitude. If the magnitude of vector A is represented as the magnitude of A, then the magnitude of its negative is also just the magnitude of A. It is very important to remember that magnitude represents a distance or a length, and therefore, magnitude can never be a negative value. Next, let's consider the direction. This is where the negative part actually happens. If we imagine vector A points towards the east, its negative vector will point towards the west. As we move to the next slide, we will see how we can express this relationship using formal mathematical notation. Mathematical notation. If we have a vector, which we'll call A with an arrow on top, its negative is written simply by placing a minus sign in front of it, like this. Negative A. It's a very straightforward way to show that the direction has been flipped. To see this in action geometrically, let's consider two specific points in space, which we will label point A and point B. If we draw a vector that starts at point A and ends at point B, we denote this as vector AB. This represents our original movement or direction. Now, if we reverse that movement, starting at point B and ending back at point A, we write this as vector BA. As we discussed in the previous slides, the length or magnitude of these two paths is identical. However, because the direction has been flipped exactly 180 degrees, we can express this relationship mathematically with the equation. Vector BA equals negative vector AB. This equation perfectly captures the essence of what we've been learning: the same magnitude, but with an opposite orientation. Now that we have established the conceptual idea that a negative vector is simply a reversal of direction, let's look at how we actually write this down using mathematical notation. Real-world example: displacement. Now that we have established the mathematical definition of a negative vector, let's move away from abstract symbols and look at a real-world example of displacement to help you visualize this concept. Think about the physical act of walking between two different locations. Let's set up a scenario. Imagine you are walking from your home, which we will call point A, to a library, which we will call point B. To break this down step by step, first, let's define our initial vector. We can represent the displacement from your home to the library as the vector D, which is also written as the vector AB. This vector carries two vital pieces of information: the magnitude, which is simply the physical distance between your home and the library, and the direction, which is the specific path leading from home toward the library. Next, let's consider the return journey. Suppose you have finished your work at the library and you are now walking from the library back to your home. We represent this return path as the vector BA. Now, let's compare these two journeys. If you look closely, the distance you cover walking back is exactly the same as the distance you covered going there. However, the direction is exactly opposite. Instead of moving from A to B, you are moving from B to A. This brings us to our conclusion. Because the magnitude remains unchanged but the direction has flipped, the return displacement, vector BA, is mathematically the negative of your initial displacement. Vector AB in mathematical terms, we can write this as vector BA equals negative vector D, or more simply, vector BA equals negative vector AB. As we will see in the next slide, it is very important not to mistake this negative sign for a negative distance, but rather to see it as a complete reversal of your path. Common mistakes to avoid. First, let's talk about a very common error, confusing magnitude with direction. It is easy to look at the notation, a negative A, and mistakenly assume that the minus sign implies the magnitude or the length is negative. However, as we discussed earlier when looking at the definition of a vector, magnitude is always a non-negative scalar. It represents a distance, and distance cannot be less than 0. Instead, you should think of that minus sign as a directional operator. It is a mathematical instruction telling you to perform a 180-degree flip in direction. Second, watch out for incorrect notation and conceptual confusion. Students often struggle to distinguish between the negative of a vector and the opposite of a scalar. Remember the distinction we made. When you are working with scalars, a negative sign indicates a value that is below 0 on a number line. But when we are working with vectors, that same negative sign indicates an opposite orientation in space. So keep that distinction clear in your mind. Scalars change value, but for vectors, we are changing direction. Now, before we wrap up our lesson, I want to pause and address some common pitfalls. As we've seen in the previous slides, the negative sign in vector algebra doesn't behave quite like the negative sign you're used to in basic arithmetic. Key takeaways. First, remember the basic notation. If we have a vector, we denote its negative simply as negative a. Next, let's look at the magnitude. As we discussed earlier in the lesson, the length of a vector cannot be negative. Therefore, the magnitude of vector a is exactly equal to the magnitude of negative a. The minus sign doesn't change the size, it only affects the orientation. Regarding direction, this is the most important part to remember. The direction of negative a is exactly opposite to the direction of a. Think of it as a 180-degree flip. Finally, let's look at the geometric relationship between 2 points. If you have a vector starting at point A and ending at point B, written as vector AB, then the vector starting at point B and ending at point A, written as vector BA, is equal to negative vector AB. All right, we have reached the end of our lesson, so let's bring everything together with these key takeaways to ensure you have a solid grasp of the concept. If you have mastered these 3 points, notation, magnitude, and direction, you have successfully mastered the negative of a vector. Well done.